Hello friends, you are watching ISC Mathematics and we are solving exercise first of chapter 4 determinants ISC class 12 mathematics. Please like and subscribe my channel ISC Mathematics. Okay, let us start exercise. We have already completed in the last video till question number 11. Yes or no? So question number 12 onwards we will start now. Okay, question number 12. We have to, in question number 12, first one, we have to prove that determinant b plus c, c plus a and a plus b, again a minus b, b minus c, c minus a, then a, b, c is equal to 3abc minus a cube minus b cube minus c cube. 3abc minus a cube minus b cube minus c cube we have to prove. Okay, so let us take left hand side. LHS is equal to b plus c, c plus a plus b. Then we have a minus b, b minus c, c minus a and a, b, c. Okay, I will add the third column on the with the first column. So this operation will carry on first column on C1. We will add C1 and C3. So we will get a plus b plus c, a plus b plus c and a plus b plus c. Then a minus b, b minus c and c minus a, b, c. Okay, so a plus b plus c is common in the first column, so let us take that common. Okay, so a plus b plus c, if we take common we will get 1, 1, 1, a minus b, b minus c, c minus a and a, b, c. Clear? Now obviously in the first column we have 3, 1, so next step is now very common. Okay, 1 minus r1 minus r2 and r2 minus r3 we can do. Yes or no? If you want to simplify one more step, we can do that. What is that step? Okay, we have a, b, c, so we can subtract. Yes or no? So let us do that one more simplification. Okay, on C2 minus C3 we will do. So we will get a plus b plus c, determinant 1, 1, 1. Okay, minus b minus c minus a and a, b, c. Okay, we are left with this. Now on r1 minus r2 and on r2 minus r3. So let us do the next step. Okay, now on r1 minus r2 and on r2 we will carry on r2 minus r3. Okay, so we will get a plus b plus c, then 0, 0, 1. Okay, minus b plus c, so we can write c minus b, then minus c plus a minus c and minus a, again a minus b, b minus c and c. Okay, now expanding around the first column, expanding along into 1 into determinant is c minus b, a minus b, a minus c and b minus c. Now we can solve this 2 by 2 determinant, yes or no? So let us solve this. Okay, so we a plus b plus c into 1 into c minus b into b minus c minus a minus b into a minus c. Let us further simplify. A plus b plus c into, okay, this is c minus b into b minus c. So if you take minus sign common, in that case, or let us directly multiply, no problem. BC, CB or BC minus c square minus b square plus BC, okay, minus a square minus AC minus AB plus BC. Clear? Okay, so now A plus B plus C into AB plus, okay, but there is a minus sign outside, yes or no? So minus A square minus AC will be now plus AC, then this is plus, and finally we will have minus BC. Okay, so this plus BC and minus BC we can reduce, so we are left with AB plus BC plus CA minus A square minus B square minus C square, and this is the formula. Obviously this is the formula. What is that formula? This is equal to 3ABC. This is an identity, yes or no? Minus A cube minus B cube minus C cube is equals to RHS. Clear? Okay, so question number 12. Number 1 is over. Now let us solve question number second of question number 12. Okay, now question number 12, second question. Here two determinants are given. One is delta, determinant delta, which is equal to ax by cz x square y square z square 1 1 1. Okay, and another is determinant is given by delta 1, which is equal to ABC x y z and yz zx and xy. Okay, we have to show that delta is equals to delta 1. Okay, what we have to show? We have to show that delta is equals to delta 1. So let us show this. Okay, we will take delta 1. We will start from delta 1. What is delta 1? Let us write down ABC x y z and y z, z x, x y. Okay, in the first column we will multiply each element with x, second column with y and third column with z, so that in each element of the third row we will have x, y, z. Yes or no? So on C1 x into C1, then on C2 y into C2, and on C3 z into C3, and therefore delta 1, since we are multiplying by x, y, z, so we have to divide by x, y, z. Okay, so we got now ax x square x, y, z. Okay, by y square x, y, z, and cz z square x, y, z. Clear? Now in the next step I will take the transpose of this determinant. Yes or no? Or I will change each row into each column. We know for a given matrix, determinant of for a given matrix A, determinant of A is equal to determinant of A transpose. So therefore delta 1 is equals to, okay, but before taking transpose, what I will do, I will take this x, y, z common from the third row. So we have now x, y, z upon x, y, z, and ax x square 1, by y square 1, and cz z square 1. Clear? So this x, y, z will get cancelled, therefore delta 1 will be equal to, okay, now I am taking the transpose. So ax by cz x square y square z square and 1 1 1. Okay, let us give the reason. Since determinant of A transpose is equals to determinant of A for a given matrix A. Okay, so done. So this is equal to delta only, and therefore we have arrived to the answer. Therefore delta 1 is equals to delta. Clear? So this question was quite easy. Okay. Now let us solve the next question. Okay, so second of question number 12 is over. Now we will solve question number 13. Okay, now question number 13. Okay, 13, number 1, we have to show that the determinant 1 plus a square minus b square 2ab to be then 2ab 1 minus a square plus b square minus 2a minus 2b 2a and 1 minus a square minus b square is equal to 1 plus a square plus b square the whole cube. Yes or no? We have to show this. So let us do this. Okay, now let us take left hand side first. LHS. Okay, we have 1 plus a square minus b square 2ab 2b then 2ab 1 minus a square plus b square minus 2a. Okay, minus 2b 2a 1 minus a square minus b square. Okay, now here I can do one thing. What I will do, I will multiply. Say, look at the first row and the third row first element. If this element is multiplied with b, so we will have 2b square, and if we add the 2b square over here, so 1 plus a square plus b square we will get. Always keep in mind what we have to prove. So we want to bring out 1 plus a square plus b square. So if you multiply third row by b, yes or no, and add to the corresponding elements of the first row, so we will get the elements which we want to be common. Yes or no? And similarly, in the next step, okay, third element, third row we will multiply with a, and we will subtract. Yes or no? We will subtract from the second row. So on two rows we will take this operation. First on row 1. So on R1, what we will do, R1 plus B into R3, and on R2, R2 minus A into R3. Clear? So first we will write down the first row element. So this will become now 1 plus a square plus b square. Okay, here 2ab minus 2ab, if you add you will get 0, and over here minus 2b. Okay, here this we have multiplied with b, so we have b minus, okay, b minus 2b plus b will be minus b, so we will get the third element like this, minus b. Okay, minus, yes, minus 2b plus b minus b minus a square b minus b cube. Clear? In this way we will get. Okay, now let us write down the elements of the second row. What we have done on R2, R2 minus a into R3. Yes or no? So we will multiply by a and then subtract. So this element will be 0. Okay, here minus 2a square, then when subtracted 2a square. So this element will be 1 plus a square plus b square. Clear? Okay, and over here this is to be multiplied with a. So 2a minus a will be a only. A plus a cube plus ab square, and the elements of the third row as it is. Okay, take the utmost care while writing these two elements in the first and second rows, because if you have done mistake over here, then you are not going to get the answer. Clear? So we have to take care while writing. Okay, now I will simplify. One more step I will do over here. So I have 1 plus a square plus b square 0. I will take minus b common, and the terms left over are 1 plus a square plus b square square, again 0, 1 plus a square plus b square. From here I take a common, so I will get 1 plus a square plus b square, and 2b minus 2a and 1 minus a square minus b square. Okay, now look at the first and the second row. You will find that 1 plus a square plus b square is common in first and second rows. So we will take from both the rows 1 plus a square plus b square common. So we will get 1 plus a square plus b square the whole square. Yes or no? Because from first and second rows twice we have taken it common. Okay, now what is left? Let us write down 1, 0, 2b, 0, 1 minus 2a and minus b, a 1 minus a square minus b square. Clear? Yes or no? So far okay. We have simplified. Furthermore, one more step. If you want to simplify, you can do. Otherwise, you can expand. If you don't want to simplify, yes or no, we will now directly expand. We can expand directly, or one more step. If somewhere you can get some 0 or something like that, we can do. Okay, so let me. So okay, now this element. Okay, over here. This I will multiply with b and add to the third column. Okay, so on C1, on C3, C3 plus b into C1 I will do. So b will be added over here. So b minus b will be 0. So we will get one more 0 over here. Then we will expand. Clear? So I hope you have understood this all the steps. Let us go through. The very important step is the first step. Okay, on R1 we have taken R1 plus B into R3, and on R2, R2 minus A into R3. So we got this determinant. We have simplified these two elements. We have taken common minus B and A respectively, and after that 1 plus A square plus B square we have taken common from the first and the second row. Yes or no? This is the determinant. Now we will carry on this operation, and let us write down the simplified determinant over here. Okay, so yes, on we have outside 1 plus a square plus b square the whole square common. Okay, 1 0 2b 0 1 minus 2a and multiplied b and added. So 0 a and 2b square. So 1 minus a square, 2b square minus b square will be plus b square. Now let us expand along the first row. So expanding along first row, 1 plus a square plus b square the whole square into 1 into 1a minus 2a 1 minus a square plus b square. Now let us solve this determinant of order 2 by 2. We will get 1 minus a square plus b square plus 2a square. Okay, so 1 plus a square plus b square into 1 plus a square plus b square. Here we have a square. Okay, now 1 plus a square plus b square the whole square into 1 plus a square plus b square is equal to the required answer 1 plus a square plus b square the whole cube, which is equal to right hand side. Clear? Yes or no? Good. So this was the first part of question number 13. Now let us solve the second question of question number 13. Okay, now second of question number 13. What is that? Our determinant is given a, b, ax plus by, then b, c, bx plus cy, and ax plus by, bx plus cy 0 is equal to b square minus ac into other bracket ax square plus, I think this is 26xy, but I think this must be 2bxy in place of 26xy plus cy square. Yes or no? So there is some printing mistake. It is not 26 but 2bxy, something like this. That we will see while solving. Okay. So we have to prove that LHS is equal to RHS. Let us take the determinant on the left hand side. LHS. Okay, we have a, b, ax plus by, b, c, bx plus cy, and ax plus by, bx plus cy 0. Okay, now we will solve. You see, if you multiply the first element by x, yes or no, and then subtract, so this will vanish. Similarly, if you multiply the second element by y and subtract, then this will vanish. The same thing will happen with these two elements. Okay, so what we will do, we will multiply the first column by x and second column by y and subtract, so we will get the two zeros over here. You can do the same with the row. Okay, either row wise or column wise, anyway you can take this operation. Okay, so now on C3 minus x into C1 plus y into C2. Okay, so we have a, b, ax plus by, b, c, it is bx plus cy, and 0, 0. Okay, we have multiplied this with x, so ax square minus ax square plus bxy minus bxy plus cy square. Okay, this is the third element, A33 element. Yes or no? Let us open the brackets so that we will get minus ax square minus 2bxy and minus cy square. So you can take minus sign common and write down this determinant in this way. Let me write down over here. Okay, so this will be AB AX plus BY BC BX plus CY 0 0 minus common AX square plus 2BXY plus CY square. Clear? Now we will expand this determinant along the third column because we have two zeros over there, so we will expand along third column and we will get RHS. So as I told, in the textbook it is 26, but actually it is 2BXY. Okay. So let us solve, do the remaining step over here. Okay, now expanding along third column. Okay, so along third column we have minus ax square plus 2bxy plus cy square into ab bc, which will be equal to minus ax square plus 2bxy plus cy square into AC minus b square. Finally we will take minus sign common from the second bracket, so minus minus will be plus and we will get the required answer. The terms will reverse, so b square minus AC into ax square plus 2bxy plus cy square, which is equal to right hand side. Clear? Okay, so question number 13 is over. Now let us start solving question number 14. Okay, question number 14. In question number 14, we have to prove that the determinant minus a square BA AC AB minus b square BC, then AC BC and minus c square is equal to 4a square b square c square. Okay, so let us prove this. Let us take LHS left hand side. Okay, LHS minus a square BA AC AB minus b square BC AC BC minus c square. Okay, now it is very evident that from the first row we can take a common, from the second b and from the third c. Okay, so taking a, b and c common from first, second and third row. Yes or no? So A, B and C we have taken common. So minus A, B, C. Here A, B, C, and again over here A, B and minus C we are left. Okay, okay, here it is minus B, again minus A, then B minus B and C minus C. Okay, done. Clear? So now again you can take A common from the first row, B from the second and C from the A common from the first column, B from the second column and C from the third column. Okay, so now it will become A square, B square, C square. Okay, minus 1, 1, 1, 1 minus 1, 1 and 1, 1 minus 1. Okay, let me write down the reason here. Taking A, B and C common, from R1, R2, R3, and here taking A, B and C common from C1, C2 and C3. Clear? Now let us simplify this little bit. For this I will add on C1 plus C2 and on C2 minus C3 I will do. Clear? This step I will do over here. On C1 plus C2 and on C2 minus C3. So we will get A square, B square, C square, and determinant will be 0, 0, 2. Then we have 0, minus 2, 2 and 1, 1 minus 1. Now let us expand along the first column or first row, any way you can expand. Clear? So very simple question. In the first step what we have done, we have taken A, B and C common respectively from the first, second and the third row. In the second step we have taken A, B and C common, respectively from the first, second and the third column. Okay, then on C1 plus C2 and on C2 plus C3 we have done. So we have arrived to this step. Now we will expand to get the final answer. Okay, so equal to A square, B square, C square into 2 into 0, 1 minus 2, 1, which is equal to 2 A square, B square, C square into 0 plus 2. So 2 A square, B square, C square into 2, which is equal to 4 A square, B square, C square, and which is equal to right hand side. Clear? Yes or no? So this was question number 14. we have done. Now let us solve the first one of question number 15. We will solve the first of question number 15. Okay, question number 15, number 1. What is the question? Okay, we have to prove that determinant is given 1 plus a1, 1, 1, 1, 1 plus a2, 1, and 1, 1, 1 plus a3. This determinant is equal to a1, a2, a3 into bracket 1 plus 1 upon a1 plus 1 upon a2 plus 1 upon a3. Okay, so this is also a simple question. Let us take the left hand side, LHS. We are given 1 plus a1, 1, 1, 1, 1 plus a2, 1, 1, 1, 1 plus a3. Okay, I will take a1 common from the first row. I will take a1 common, a2 from the second, and a3 from the third. So taking a1, a2 and a3 common from R1, R2 and R3 respectively. So A1, A2, A3 we have taken common outside. What is left? 1 upon A1 plus 1, 1 upon A1, 1 upon A1, 1 upon A2, 1 upon A2 plus 1, 1 upon A2. Similarly, 1 upon A3, 1 upon A3 and 1 upon A3 plus 1. Clear? Okay, now what we can do, we can add on R1, R1 plus R2 plus R3. Okay, so on R1, let us add R1 plus R2 plus R3. So we will get A1, A2, A3 we have taken common outside. Okay, now we can write. Okay, let us do one thing. This step will require a space, so I will do this step over here. You have understood this one step what we have done. This is left hand side. We have taken A1 common from the first row, A2 from the second row and A3 from the third row. So these elements are left now in the determinant. Now on R1 we will do R1 plus R2 plus R3. So that step will be done over here only. Clear? So I will remove this. Okay, so let us add. Okay, we have A1, A2 and A3 outside. Okay, so on 1 plus 1 upon A1 plus 1 upon A2 plus 1 upon A3. Similarly, 1 plus 1 upon A1 plus 1 upon A2 plus 1 upon A3. 1 plus 1 upon A1 plus 1 upon A2 plus 1 upon A3. Okay, 1 upon A2, 1 upon A3, 1 upon A2 plus 1, 1 upon A3 and 1 upon A2 so let us take it common now. Step okay, so a1 a2 a3 into 1 plus 1 upon a1 plus 1 upon a2 plus 1 upon a3. What is left? That is 1 upon a2, 1 upon a3, 1 upon a2 plus 1 upon a3, then 1 upon a2, 1 upon a3 plus 1. Clear? Now on C1, C1 minus C3 and on C2, C2 minus C3. I will subtract the third column from the first and the second columns respectively in the next step. Clear? So these steps are clear, I hope. Yes or no? Good. So now let me remove. Okay, so now on C1 minus C3 and on C2 minus C3. So A1, A2, A3 into 1 plus 1 upon A1 plus 1 upon A2 plus 1 upon A3 into 0, 0, minus 1, 0, 1, minus 1 and 1 upon a2, 1 upon a3 plus 1. Clear? Now we will expand along the first. In the last step we will expand along the first column. Okay, so we have okay, now let me write down that expanding along first column. Okay, we will get a1, a2, a3, 1 plus 1 upon a1 plus 1 upon a2 plus 1 upon a3. Okay, into minus 1 into determinant is 0, 1 upon a2. Okay, so if you simplify, you will get a1, a2, a3, 1 plus 1 upon a1 plus 1 upon a2 plus 1 upon a3 into minus 1 into minus 1. So minus minus plus 1. So final answer will be this only, which is equal to a1, a2, a3 into 1 plus 1 upon a1 plus 1 upon a2 plus 1 upon a3, and which is equal to right hand side. Clear? Okay, so question number 15. First one is also over. Okay, let us solve one more question number 15, second one. a plus 2b, a plus b, a plus b, a plus 2b, and a plus 2b, a plus b, and a equal to 9b square into bracket a plus b we have to prove. Okay, let us take the left hand side. LHS is a plus 2b, a plus b, then a plus b, a plus 2b, and a plus 2b, a plus b, and a. Okay, on R1 or on C1, anyway you can take. On C1 plus C2 plus C3, we will add the 3 columns on the first column, so we will get 3 into bracket a plus b. Yes or no? 3 into bracket 3a plus 3b we will get. We can write 3 into a plus b. Second and third, let me write down as it is. A plus 2b, a plus b, and a. Okay, so we will take now 3 into a plus b common. So we are left with 1, 1, 1. A plus b, a plus 2b, a plus 2b, a plus b, and a. Okay, now on R1 minus R2, and on R2 minus R3 we will do. On R1 minus R2, and on R2 minus R3. So 3 into a plus b, 0, 0, 1, b minus 2b, a plus b, b, and a. Clear? So we get like this. Now from the first and the second row we can take b common. In the first row we have b, and in the second row also we have b. So 3b square into a plus b, 0, 0, 1, 1 minus 2 a plus b, and 1, 1 a. Now finally we will expand along the first column. Clear? So first step was adding the 3 columns on the first column. 3 into a plus b we have taken common. Then R1 minus R2 and R2 minus R3 we have done. Okay, then we have taken b common from first and second row, and now we will expand along the first column. Okay, expanding along first column. So 3b square into a plus b into 1 into 1, 1 minus 2, 1, which is equal to 3b square into a plus b into 1 into 1 plus 2. So 3b square into a plus b into 1 into 3. So 3 3s are 9b square into a plus b, which is the required right hand. Clear? Okay, so 15th second one is also over. Today we have started question number 12 onwards. So 12, 13, 14 and 15, there are 3, we have done 2. Okay, further questions we will solve in the next video. Clear? Thank you very much.